Hello everyone, I am Omachi from Yahoo Japan. So today I would like to talk about the end-to-end automatic speech recognition for running on edge device development. Let me introduce myself. So I joined the Yahoo Japan in 2016, and since then I am engaged in automatic speech recognition development. The major topic of the research is end-to-end automatic speech recognition. And recently, I did the presentation at the top conference of the ASR and also natural language processing. And also, I am involved in the ASR SDK development and also the ASR server side. Especially, I am the person in charge of the ASR SDK development. Today's presentation, I would like to talk about the end-to-end ASR, which I released recently. End-to-end ASR does not have any communication outside, and voice ASR is performed on edge. So first, I would like to talk about the current ASR system, YJVOICE. And after that, I would like to talk about the popular end-to-end ASR techniques, and also I would like to address some issues when we run the ASR on edge device. So first, I would like to talk about the YJVOICE, which is the Yahoo Japan ASR engine. ASR is to assume the text of speech from the user's voice. By using this technology, it is possible to realize the voice search or a dialogue type agent. YJVOICE has been developed by Yahoo Japan since 2011, and this is a proprietary ASR. And currently it is used for speech and dialogue, and it is used by many Yahoo Japan applications. It can output more than 1.5 million words. In our project, to verify latest ASR technology, we offer the 音声検索 lab application as a lab application. So let me explain how to realize ASR with the current YJVOICE. So this is the client-server type ASR. First, the user's voice is picked up by a smartphone, and this sound is uploaded to the server. Then the server will run the ASR. Then the ASR result is returned to the smartphone, so user can get the text corresponding to a user's speech. However, the current YJVOICE has three issues, which are stability, user privacy, and latency. First, that it requires communication. So if the communication with server is disconnected, it cannot run the ASR. And also, there are a certain number of people who don't want to send your voice to the server. So for such people, it is not easy to use the ASR system. And furthermore, in the environment of the slow communication speed, it takes time to get a result of the ASR. To solve these issues, we have released the on-device ASR, which process the ASR on edge device. So on-device ASR does not require the communication with server, so it doesn't have any issue of the stability and latency. And also, people who don't want to send their voice to the server, they can easily can use the ASR technology. So this is the advantage. And this function is also implemented in our 音声検索 app, which is our lab application. 音声検索 app is downloadable from Apple Store, so if you are interested in, please download it. In this slide, the current YJVOICE and also the 音声検索 app is also displayed. The left is the server client ASR and the right is the on-device ASR. So you can get that. You can see that on-device ASR can get the result faster, and also accuracy is closer to the current YJ voice. Next, I would like to talk about the end-to-end ASR, which was adapted to realize the on-device ASR. Before explaining end-to-end ASR, I'd like to explain about DNN HMM hybrid ASR, which is used by the current YJ voice. So first, the sound is picked up by the microphone and the acoustic feature amount is extracted for ASR.
However, this includes interval where there is no utterance by user, which means it takes a longer time for processing. Therefore, for the technology we use for detection of audio intervals, so that utterance of acoustic properties can only be captured. Using this, decoder is a module we use to infer the most likely text. And decoder, in order to implement decoder using acoustic properties model, pronunciation dictionary, and language model, 3 models are in use to infer the text. And as for acoustic model, shita, a sequence of phoneme will be inferred, and pronunciation dictionary will map the sequence of phoneme to the sequence of words. The point I'd like you to be careful about is that a conversion from phoneme to words is not necessarily unique, and there can be multiple notation that may exist. Therefore, you can come up with candidates of multiple sequence of words here. As for language model, among multiple number of sequence of words, it will identify the natural model. This is to measure the interval between words, and ultimate output will be shown as a result of speech recognition that is most likely based on multiple series of words. Like this, we need 3 models for DNN HMM hybrid ASR. Pronunciation dictionary and language model would not require audio information. Therefore, using a latest search query, we can train model, and the buzzwords can be also supported, which is the benefit. However, lots of memory and computing will be required. Therefore, edge device with resource limitation would have a difficulty in doing this. In order to resolve this issue, we have end-to-end speech recognition method to realize on-device speech recognition. As for end-to-end speech recognition, using 3 models that will be replaced with a single neural net. With this technology, it is drawing attention in the research support, and a variety of paper is presented at international conferences. And end-to-end speech recognition is more advantageous than DNN HMM hybrid speech recognition with 2 items. First of all, simplicity is the benefit. DNN HMM hybrid ASR system need to be developed, and it is necessary to have expertise and knowledge in terms of voice, language, and exploration. Therefore, it will be difficult to train model and implement that. On the other hand, as for end-to-end speech recognition, neural network will be the main module, which means it's simple in terms of the configuration. Therefore, compared with the DNN HMM hybrid ASR, it is relatively easier to implement. The second benefit is the size of a model. If you replace DNN-HMM hybrid ASR model with a neural network, model size can be greatly reduced. In the case of YJVOICE, as an example, on-device speech recognition model will be reduced by 1/100 compared with the model using servers. And end-to-end ASR, there are 3 models using end-to-end ASR. Main one is encoder-based transducer, attention-based encoder-decoder. Those are the 3 ones proposed. First of all, encoder-based model, encoder network, based on which acoustic properties will be inferred to assume text. The main one is a connectionist temporal classification, CTC, is proposed. As for CTC, it will calculate probabilities of all the sequences that can be output to come up with the most likely candidate. As for RNN transducer, it is an extension of encoder-based method. If it is based on encoder, especially for CTC, relations between text to be output are not explicitly considered. Therefore, RNN transducer is utilizing a prediction network and a joint network so that it can confirm the strings that were output in the past to infer the current output. Therefore, compared with the encoder-based model, accuracy will be improved, which is also the benefit. As for attention-based encoder-decoder, natural language processing is where it is used. By introducing a structure named attention, acoustic properties for entered data will be considered. Accuracy will be higher than encoder-based RNN transducer. However, you cannot get the result until utterance of a user is completed. Therefore, it's not appropriate for real-time required speech recognition. I'd like to make a summary of 3 models' pros and cons. First of all, encoder-based method, even during the utterance, streaming processing can be done, which is the benefit. However, CTC method is ignoring the relationship of multiple outputs. Therefore, there is room for improvement.
So RNN transducer is possible to do streaming processing, and the accuracy is higher than the encoder-based approach. So this is the advantage. On the other hand, compared to a CTC, the model structure is a bit complicated. So it is difficult to do the learning of the model, and also implementation is difficult. And the attention-based model, among 3 models, it can achieve the highest accuracy, but to do the streaming, you need some tricks. So the YJVOICE needs streaming capability. So to apply this model is difficult. So considering those points, we released in April the beta version encoder-based model, and also as official version in October we released RNT model. So I would like to introduce the related End-to-End ASR SDK and related research topic. So to develop the End-to-End ASR SDK development, we established the SLA for OS real-time factor and accuracy. As OS, to support both iOS and Android implementation is done in that way. So the core library is implemented without depending on OS, and separate wrappers for each OS is prepared. And in this way, we address this OS. And in terms of the ASR execution time, the real-time factor, the RTF, is set less than 1.0. RTF is the indicator to represent the recognition process speed. So the process time is divided by actual voice length. For example, the 10-second voice is processed with 1 second. The RTF is 0.1. So if this value is less than 1.0, this was confirmed with iPhone 11 Pro. The accuracy. We set the minimum target, get close to the server-side ASR. The details will be covered in the next slide. This figure is the performance of the model we released this time. And the vertical axis is the ASR error rate. Lower is better. From left, the encoder base, this is released on April. And the RAN transducer released on October. And also the DNN HAM ASR currently running on the server side. So the first encoder-based model, compared to the DNN HMM hybrid, there is a performance gap, about a 4.7-point gap. And RNN transducer, it is close to the DNN HMM hybrid type. So in terms of the performance, we can get we confirm that the performance is close to the DNN HAM hybrid, but still we have quality issues. So we would like to share some issues that we are addressing. First, the end-to-end, the ASR, has difficulty to output the vocabularies not in learning data out of vocabulary. So to be used by many apps, so it is necessary to output the buzzword and address and proper nouns. Also, the end-to-end model cannot get the reading information. End-to-end model can output the spelling and also the reading information. Then it is possible to identify the heteronym like Nihonbashi and Nipponbashi. So it can be applicable to navigation system. So to address these issues, how we address these issues, I would like to explain. First, let me talk about how we addressed to the unknown word or out of vocabularies. But first, I would like to briefly talk about the ASR model training. So first, among the learning data, we have to extract the voice data, and also we have to assume the voice recognition result. Then also we have to calculate the delta between the result and the pre-transcribed text. And also we update the model parameter to minimize the gap. By repeating this process, the model can output a closer result to the transcription. So the speech recognition model training is performed in this way. So without the latest voice transcription, the model cannot output a buzzword. To solve it, we are studying the method using untranscribed speech. First, transcribed speech is entered into the DNN HAM hybrid ASR, and we can get a pair of the data of the voice and also the recognition result. DNN HMM hybrid ASR can learn the language model and can also output the latest words. Using this, so even though the words is not included in the data, it can extract the voice the sound and also the word. By adding such data into the learning data, we can expand the coverage of the unknown words.
This diagram is indicating speech recognition result of unknown words. Vertical axis is the error rate of ASR, and the lower it gets, the better the performance will be. As for transcription, DN and HM speech recognition result will be added to improve speech recognition error rate by 19.9 point. Next, for the issue where reading cannot be inferred is what I'd like to talk about. What I'm going to talk about is there is a top conference of natural language processing, NACO. That is where I presented. And for details, if you refer to a paper, I'd be happy about that. And as I mentioned earlier, as for the current end-to-end ASR output, transcription notation examples will be utilized. However, this could result in an issue in some cases. For example, as shown in this case, from a recognition result, user may say how to get to Nihonbashi or how to get to Nipponbashi. It's difficult to know which utterance was done, and using the result of speech recognition for navigation, Nihonbashi in Tokyo is totally different from Nipponbashi in Osaka. The totally different location can be navigated. And one way to resolve this issue, ASR and natural language processing can be combined as a pipeline system for the output of speech recognition. Reading will be inferred by natural language processing. However, there are two issues on this. First of all, if there is an error in speech recognition, you fail to infer reading, to come up with the wrong way of reading a text. And in order to run natural language processing, more resources will be required. Therefore, if you want to run it on edge device, it's not desirable. Therefore, we proposed a framework of inferring both notation and reading for E2E speech recognition. E2E speech recognition model will be output, and it will be replaced notation of each word with a sequence of reading. With this, you can easily capture notation and reading from output. And as I mentioned earlier, we have an issue that it's difficult to infer unknown words. But even if there is an incorrect notation with this method, it will be easier to identify the content of utterance. Furthermore, with this method, additional memory and resources for computation will not be required. Therefore, there is better affinity in terms of having a behavior on the on-device method. There are two cases I'd like to introduce with this method. This is attention-based encoder-decoder. Model training is utilized mainly with the public corpus. The one at the top means spectra and spectral. This is the audio that was replaced between those two. With natural language processing, rephrasal is not clearly divided. However, for the proposed method, using audio recognition, you can divide the rephrasing interval. Next one is about homograph. If there is language information, you can't identify if it is sonogo or sonoato. And as for the proposed method, you can utilize audio information. Therefore, you can decide it in a unique way. And this is what we'd like to adopt. And in the future, notation and reading should be output in the production environment in the future. And there are other initiatives I'd like to introduce. First of all, there is a self-supervised learning, SSL. As for end-to-end speech recognition, if you increase training data, it will improve performance, but there will be requiring a pair of audio and transcription. And in order to prepare this pair, cost will be required. As for SSL, volume, a great volume of audio which is not transcribed can be utilized for learning audio recognition. Using this method, a higher performance of high on-device speech recognition can be offered. It is also necessary to consider improving latency. By the time speech recognition result will be captured. As for smartphone application initiative, we have to minimize the time you can get the result for speech recognition. To resolve this issue, we are considering to impose constraint so that the latency can be minimized for RNNT learning. And Yahoo Japan's audio team has released a paper, and most recently, TAP Conference, ICAPS 2022, and InterSpeech 2022 adopted our paper. Last but not least, I'd like to talk about Yahoo Japan's research activities. This is about a list of a paper for end-to-end audio recognition, including co-authoring from 2020 ICAPS InterSpeech TAP Conference, the platform where our paper was adopted. And we will continue to research and develop with our team. Lastly, I'd like to summarize this session. In this session, E2E speech recognition SDK, which we released, was addressed. As for end-to-end speech recognition, it's possible to make edge device work, and it is resolving the issue where client-server type speech recognition had, and user privacy and latency from communications are addressed. And as for accuracy, it is close to client-server type speech recognition, but we still have remaining issues. And I'd like to talk about notation reading can be inferred at the same time. This concludes my presentation. Thank you very much for your patience. Thank you very much.
題して質問者
So, Mr. Omachi, thank you very much. So we would like to move on to the plus talk session with the questioner. The session content will be dived deeper through Q&A. We will entertain questions from audience as much as possible. You can post your question by question mark icon on the screen. Questioner is Mr. Yu Nakagome from LINE. Nakagome-san, please. So I am Nakagome from LINE. So I am working on the end-to-end the ASR at LINE. So thank you very much for interesting presentation. I have some questions. So first, the edge device ASR. So the model memory amount and also the computation amount, I think there are some limitations. So the size of the model gets smaller, or the computation amount should be smaller. So I think you so are you using kind of a compression technology to make capacity smaller? So to run on the edge device, there is a limitation of the model, and so the current model is that the accuracy has to be guaranteed. So the structure itself is going to be improved from now on. So we need to study that and make the model granular. Then we try to compress the size of the model. Concretely speaking, about several 10 mega size, the model size gets smaller. Thank you. So to the out of or the unknown words coverage, I am interested in. So about the unknown word, so in a Yahoo service, it can actually recognize the words in a general manner or generic manner, or in a certain area, these types of the words should be identified correctly. So do you have any constraints or limitation in terms of the unknown words or out of vocabularies? So in terms of the generic, I think it is a bit difficult, but the YJ voice is used for voice search, but also it is used for the dialogue. So in each domain, we developed technology to identify the words. On-device recognition, the search is the main usage. So to identify the latest buzzword has to be is mandatory, and also so if there is a request from the service side, yes, we do have such a request. So we would like to address that. So we are customizing to fulfill such needs. And so I think your approach is very interesting. So DNN HM recognition result is used. Then so the voice data without label get the temporary label, then so you solve the issue in that way. So I think it is very interesting approach. And so DNN HMM recognition result, of course, the recognition error is also included. And so that may make a negative impact on the learning. So do you use the filtering for the learning purpose? So is there anything that you do or you apply to improve the learning data? So I cannot share the concrete approach now, but so the DNN HMM, the voice recognition error is created. So of course we address that. So sorry, I cannot share how we did it actually. Concrete information, I cannot share that with you. Sorry for that. And so I have another question on model. So RNNT you used, and the outside the language model is also used, and to address the unknown word, I think you used the outside the language model. Or whether you take such approach or not, I would like to know. The outside language model for the on-device approach, we don't use it. And of course, by using the outside the language model, it will improve the coverage of the unknown words, and also the recognition performance will be improved. But considering the on-device, there is the memory limitation, so it is difficult to use the third-party or outside language model. Of course, if we can use the server, it is possible to use such language model. But this time, we don't use it.
And in the future, when we have more unknown words, how we can reinforce recognizing unknown words, which is a question I have. DNN-HMM may be adopted for speech recognition, based on which, if we can train models, we can do that. But on edge device, memory amount may have a constraint. Model size cannot be enhanced, which is also the constraint. And we want to recognize various words, but model parameters that can cover that will not be available. I think we will probably have such an issue in the future. Do you think? Your question was rather difficult to answer. As for unknown words, if we expand the coverage, if we increase the model size, we can increase vocabulary. But to what extent we should define unknown words? Because when it comes to words, there are old or obsolete words, and we should follow new words. That would be easier for us to come up with a good search result. So model size and the query output, there is a trade-off we have to consider for our future development. Yes, I agree. If there is upper limit of model size, we should be able to recognize more frequently used words, and less frequently words may not be considered. Yes. Among models that may be processed. Thank you very much. And as for unknown words, I think I covered all the questions, but for reading can be inferred at the same time as a notation. That is what I'd like to ask a question. What I'm interested in is reading can be inferred at the same time. Then recognition accuracy may or may not be improved. That is what I'd like to ask. Reading using Chinese characters. Chinese characters can be recognized with more accuracy. Yes, that is what I was originally considering. But according to the information we released in the paper, but the notation would not be considered. Of course, among models, relationship may be considered. That may be their methods that will be more popular, but we use the public corpus for this, and if we use a different corpus, it may be different. Comparison is maintained. For the detailed structure is what I'm not sure, but multi-loss or multitasking action may be taken place. But for that, you try hard so that the notation would not be deteriorated in terms of its performance. Yes, comparable with notation. Thank you very much. And I have a last question, maybe. For Yahoo Japan, we have an on-device streaming of speech recognition. What is the significance of what you do at Yahoo Japan? In this session, dialogue is one of the keywords you used. And when you apply this technology to what services you'd like to do in the future, could you tell me the outlook? Yes, thank you very much. In terms of what specific services that will be available, I cannot respond to you. It is about generic issue in terms of on-device and user privacy, and also communication will not be required. Those are the benefits for on-device method, and we can do so. As for user privacy, if assurance cannot be done because of privacy, it should be better to process on device rather than sending it to servers. So we can cope with the utterance. And in terms of communications, if communications are not required, there are many ways we can adopt communications. Don't have to be made at all the time. It doesn't have to send a server. If a response is given right away on device, that must be easier for customer. And in terms of on device general policy, there are many ways we can apply that technology, which I'd like to think about. Thank you very much. It is a very exciting topic. I enjoyed your presentation. Thank you very much. Thank you very much.